things about time series for a long time. So nowadays, of course, the time series, they are ubiquitous. You can find them everywhere in the world, in economics, demography, sociology, and so on and so on. And if we think about the definition of a time series, this is important. Do not think that it's just a soft talk. It's something important for you to understand the background of seasonal adjustment. So if we can try to define a time series, we will say something like it's a set of observations which are characterized in particular by the order in which they have been collected. So the order in which they have been collected. This is a very general definition. In economy, we could slightly transform it in, for example, a set of values of a variable collected at regular dates. So yeah, I put in bold some words, in particular, values, variable, and collected at regular dates. In fact, this is probably this kind of definition you would have written if I ask you to define a time series. This is what we have in mind, okay? But in fact, it's not at all very clear. If you think about the words, okay, it's a set of values. So it means that we are going to work on number, on figures, okay? But time series are not always figures. For example, in your field, in the economic field, we are used, a lot of national statistical institutes are used to collect business survey data, business tendencies survey data, to record the short-term evolution of the economy. So it's a pool survey. You ask the businessman if the situation is of the current month or current quarter is stable, worse or better than the previous one. Okay, so it's not a figure. It's just yes, it's better. No, it's not, and so on. And so after, the first work you have to do is to transform these kind of opinions in values. Okay, probably the two other remarks are more important. So it's of a variable. A variable, I mean, it's not so easy. If you think about the industrial production, it is clear that the industrial production is certainly not the same today than it was 10 years ago in any country. It changed a lot. And as statistician, you know that you have sometimes very difficult tasks to perform, which are changes of classification or, for example, rebasing and things like that, okay? So in fact, you do not have it's because the definition of a variable is moving. For example, the industrial production is changing, but you have to adapt your classification and you have to rebase your data and so on. So this is, I mean, a variable is something that does not exist. Usually the variables are changing. I'm not saying that the production itself, the numbers, are changing. Of course, they are changing. They are increasing, decreasing, they are seasonal or whatever. I mean that the contents of the production itself is changing. For example, 20 years ago, we were used to produce cathodic screens for the TV. Okay, nowadays it's nobody produces cathodic screens. You use LED screen, flat screens. It's completely different. So you do not have the same product. So the content of the production itself is changing. Okay. And the last thing, so it will have an impact on our practice, because we already discussed that a bit yesterday, because it will be difficult to consider that a long time series is just one variable. Okay, it's okay. We agree where we give the same name to the variable, but the content of the variable changes. And the last thing is regular dates. So we say, for example, yes, we are going to record the data every month, every quarter, every year. But unfortunately, quarters and months are not equivalent. For example, a month might have 28, 29, 30, or 31 days, okay? So between a February with 28 days and a March with 31 days, you have 10%. You see, you have 3 days more, so 10% more or less, which is big. So they are not. So by construction, if I can say so, the production of March should be greater than the production of February because you have more days. This is the first thing. The second thing is that even the number of the content of the month could be different. For example, for in a month, usually you can have 4 or 5 Saturdays, depending on the month and depending on the year. So it will be very different, for example, for retail trade to have 4 Saturdays in a month or 5 Saturdays in a month. Because in most countries in the world, Saturday is the shopping day. So you go shopping on Saturday, and then the retail trade make a lot of business this day. So a month with five Saturday will be much more interesting for the retail trade than a month with 4 Saturday only. And it does not matter. And obviously, you will have a bigger turnover in a month with 5 Saturday, which does not mean that the economy is going better, just the fact that you have 5 Saturday in this month. So think now that what I'm just saying now is why sometimes you have trouble with yearly growth rate, year-to-year growth rate. Because, for example, you will compare for retail trade a month of March on 1 year with 4 Saturdays, with a month of March the previous year with 5 Saturdays. So you will see a decrease, which is not due to the economy, but due only to the calendar, just a calendar effect. So you see that this definition that seems pretty basic and pretty clear is not clear at all. And we will have a lot of things to deal with, in particular the definition of a variable, in particular the dates. So it's and the last thing is that it's very, very different from usual survey data. When you conduct a survey, you might have a sample size of 1,000, 2,000, 3,000 people, okay, or businesses. It's usual, okay, at least several hundred. But here, when you are doing with quarterly data, you only have 4 observations a year. So for 10 years, you only have 40 observations. So you will have to deal with that, which is the fact that you do not have a lot of information. And then you will have to do some hypothesis on the data generating process to be able to do some computation and to, at the end of the day, to be able to comment the short-term evolution of the economy. So keep that in mind. Very different from usual survey data and very complex data because you do not have a clear definition of a variable. Of course, you have a clear definition of the industrial production index now, today. But if I ask you what was the definition of the industrial production index 20 years ago in your country, you will not be able to answer, okay? And very often, think about our data. Our data usually, for a lot of countries, they have been reconstructed. So Yesterday we saw GDP, and I told you that for me, this GDP has been backcasted by statistical methodology. So even the GDP is not the GDP. It is clearly not the GDP. It has been reconstructed from another indicator, probably a monthly indicator. The people did a good job, I'm sure of that, but this is not the GDP. It has not been observed. It's not even the GDP. It's a statistical model plus an indicator, which is not the GDP, but which is supposed to be linked to the GDP. Okay? So it's very, very different. So let me continue this grand tour, historical grand tour. So at the beginning of the 17th century, you have the Keplers Law. This is important, you will see. You will see it's not just soft talk. So Kepler stated that the Earth has an elliptic motion around the sun. So everything is, when he, something like that, he didn't say that exactly, but it was the substance of his theorems. Basically, so it's completely deterministic. If I know the time, I will exactly know the position of the Earth around the sun. No error, nothing. But when people did some accurate measures, they appear to be contradictory with these laws, with Kepler's laws. And in fact, they saw that they have more fluctuation around a theoretical position. I mean, do not think that at that time they were not able to make very, very, very accurate measures of astronomical measures. They were incredibly good, incredibly. You cannot imagine. We will perhaps discuss that when we will talk about the calendars. But for example, you have to know. Let me tell you that, for example, the Muslim calendar, the Islamic calendar, is incredibly precise. In a cycle of 30 years, the length of the lunar year is close to the astronomical year. It close at 35 seconds. It's incredible. They were able to do very, very accurate measures. So when we say there's something wrong in Kepler's law, we have some kind of fluctuation around the theoretical position, they are right. They were right. Kepler's law were wrong. They were just approximate laws, okay? So they were right. And we discovered sometimes after that, in fact, the orbits of the planets were changing, and you had secular and periodical movements. So let me think about that. So what they are saying, in fact, is that if I consider my variable is the position of the Earth, the position relatively to the sun, I have a theoretical position, which is given by Kepler's law, plus a secular movement, plus a periodical movement, plus a fluctuation, an irregular due to the precision of the measures. So, and the only thing you observe is the position of the Earth. So you have what we call now, we call that today, the unobservable component model. So we observe one thing, and this thing is the result of several other things. A theoretical position, we could call it, for example, a trend cycle, a secular, a periodical movement, for example, the seasonal component, and the irregular, which will be the irregular. So in history, they were used to deal with some kind of unobservable component model. That's why they did a lot of work on this kind of model. But from astronomy and meteorology to economy, it took a long time. And it just go to economy, this conception of unobservable component in the late 19th and the early 20th century, okay? So it's an older story, but the theoretical background is quite recent. So let me just give you an idea of things. At the beginning, it was just graphical analysis. When I say just graphical analysis, do not misunderstand me. I'm not saying that it was not a good analysis. We will still do a lot of graphical analysis, but there was no theoretical analysis behind. The first mathematical works are dated from the 18th and 19th century, and they are incredibly important, incredibly important. Most of the works we are doing now with time series analysis are related to the theorem of Jean-Baptiste Fourier in 1807. So it's a very old thing, and we are still using it. In particular, you might know some words like the fast Fourier transform, spectral analysis, and things like that. Everything is based on the works of Jean-Baptiste Fourier. So it's a very old theory. The first seasonal adjustment I am aware of is from a Dutch guy, Buys-Ballot, who did a modeling in 1847, so a long time ago, to explain the crops of the Dutch economy. After you have the harmonic frequency, I'm quoted it because it's an important thing in time series analysis. We will probably study it a bit in the more advanced course on seasonal adjustment, because some of these results are used to detect the seasonal component. And so we are at the beginning of the 20th century, and the first definition of components and decomposition in trend, cycle, seasonality, and irregular can be seen in the works of Lucien March at the beginning of the 20th century, but more in the works of Pearson in 1916 and 1919. So it's an old story. Let me continue. The stochastic point of view, so what I call the ARIMA models, I will just tell you a short bit about ARIMA modeling because it's quite technical. We will study them probably in the advanced course, but not in this introductory course. It is dated from 1927, so very early in the 20th century. Stochastic processes, a lot of work in the 30s and 40s. The first industrial, I would say, industrial program for seasonal adjustment is X11. It's coming from the United States, and it was in 1958. A state space model with a Kalman filter and things like that are in the early 60s. And the incredible work of Box and Jenkins is from the 70s. So why do I quote all these works? It's just to show you that all the technology, the statistical, the mathematical technology is dated from before the Second World, okay? So it was in, let us say, in the first part of the 20th century. So there is, I would say, 98% of what we are going to use to analyze a time series is based on very old stories. We know that for years. The point is that it's a thing to know it from the theoretical point of view and to be able to apply it. And unfortunately, a lot of things discovered in the 20s and 30s were mathematical theorems, and we were not able to do the computation before the computer, okay? So it was not, we were not able to do that really seriously before the 70s. We were able, the computer dates from the 50s, but at the beginning, the computation were quite simple. So you remember what I caught yesterday? In the late 19th and early 20th century, the aim of many studies was to reveal the cycles in order to explain and predict economic crises. When you have that in mind, of course, short-term periodic components are of very little interest, and you focused only on the cycle, and it was expedient then to eliminate them. This was the quotation of Jevons I presented yesterday. It's an important quotation because you see exactly a lot of things. We are in 1862, and he said, every kind of periodic fluctuation, whether daily, weekly, monthly, quarterly, or yearly, which means that in these times, to have daily or weekly time series was the common day. I mean, it was a common thing to have daily and weekly series. And by the way, if you make some historical studies, you will discover that at the beginning of 20th centuries, we had a lot of weekly time series, especially for prices. And they were used to deal with weekly time series. So now we discover again what are daily series or weekly time series, but theory exists already. Okay. So let me now come to a point which looks very, very simple too, but it's not so simple. You will see that. So how can I define the components of a time series? I say, you remember the unobservable component. My time series, X sub t, could be decomposed. For example, if we follow Pearson's in 1919, into a long time tendency or secular trend. Second thing, a wave-like or cyclical component, which is superimposed upon the secular trend. Okay, so this is this is exactly the quotation from Pearson. So the rise and fall constituting the business cycle. So this is already an old thing, the concept of business cycle. And after you have a seasonal movement and a residual variation. Look at this definition of a residual variation. It does not say an irregular variation. He said a residual variation, which is, by the way, the definition is that in this residual variation, as it is a residual, you will find all the things that are not in the other components. So, for example, you might have outliers such as wars or national catastrophes, okay? So you see this definition gives you a lot of ideas on the contents of each component. Okay, nowadays, what are we doing? We can decompose the row series in several basic components. So the first component is what we call the trend cycle component, which is the trend as defined by Pearson's before, the long time tendency or secular trend, and the cycle. Unfortunately, because our series are quite short, and because this is not really the objective of seasonal adjustment, we are not going to extract the cycle. The objective of seasonal adjustment is to adjust from seasonality, seasonal adjustment. So the objective of seasonal adjustment is to estimate the seasonal component. So it's not to estimate the cycle. Even if from time to time you will use a trend cycle as an intermediate in the computations, okay? but this is not the objective. So usually in seasonal adjustment, you do not make the decomposition, and you say, okay, when people are interested in business cycle, they will use other technologies such as, for example, the Odrick-Prescott filter or over Baxter King filter or whatever, okay? So the second basic component is the one that really interests us. This is the seasonal component, the seasonality. And you have also another very short-term variation of the economy and quite regular, which are the calendar effects. In the calendar effects, you have two different effects. The first thing is the decomposition of the month, what we call, for example, I will make the difference later between the two words, which are completely similar in English. They are completely synonyms, but for curious reasons, in seasonal adjustment, we give to working day or trading day a very different signification. I will explain that later. So you have the working day or trading day component, which is basically due to the fact that the decomposition of the month on the quarter is not similar from one quarter to the other or for 1 year to the other. And you have a second calendar effect, which is the public holidays and the moving holidays. So the working day or trading day component does not depend from the country, okay? This is just due to the number of Saturdays. Let me be very simple. And the second one is completely linked to the calendar of a country, to the national specificities. So you have moving holidays, and moving holidays, you have very different moving holidays, Easter, Ramadan, Diwali, Chinese New Year, and so on. And each of them might have, in some countries, a very big impact. Okay, we discussed already that yesterday in Chinese for the Chinese New Year. So it is clear that it will depend on the country. You have 8 countries, I guess, if I remember well, in ASEAN, yeah? Something, yeah? How many countries in ASEAN are members of ASEAN?
10 countries.
10 countries.
10? Okay, so you have 10 different calendars. It's clear, okay?
Yes, yes.
These calendars might have some similarities, but basically they are different. So you will have, to a certain extent, you will have to take care of these national specificities, which is a bit difficult. Okay, this is why we are not going to talk we are going to talk about national calendars, but not a lot. I'm going just to give you the background tomorrow or the day after, I do not remember. But we are not going to work with them. That's why I focused on quarterly time series, because quarterly time series very scarcely present trading day effects or moving holiday effects. Okay, so that's why. Okay, and the last component is the irregular component. You can, so just to try to summarize things. So the trend is the long-term evolution of a series that can be observed on several decades. So basically, if you remember yesterday, the Indonesian GDP is basically, roughly, basically a straight line. It's a straight and increasing line with a decline due to the COVID crisis at the end. So this is a line, okay? So it's really the structural variation of a series, and that you can only observe on a very long period. Okay, usually you are going to consider it as a smooth component with no sudden variation. You might have a sudden variation when you have a big crisis, such as the COVID crisis, but usually you do not have this kind of variation. So it's difficult to estimate this component because we have short time series, okay? And I said, okay, perhaps on a very long period, perhaps the crisis, the COVID crisis will appear to a turning point in the cycle and not in the trend. So it's usually it's not. It's a very smooth evolution, the trend. Okay, the cycle, the cyclical component, the cycle is more smooth and quasi-periodic, which is the problem. Quasi-periodic movement of a series that can usually be observed around the long-term trend. So it's a succession of expansion and recession periods whose duration varies between 3 and 10 years. The between 3 and 10 years, this, let us say, definition comes from Burns and Mitchell in 1946 in their work on the business cycle. But remember that Pearson already defined the business cycle, okay? But the difference between the two works is just the fact that Burns and Mitchell said usually the period is between 3 and 10 years. I'm not going to discuss that now, but I will do that in the next training. But other economic cycles have been defined by economists, in particular by Schumpeter. And there was a huge fight, not only a controversy, but really a fight between economists and statisticians at that time. I will discuss that later. Later, okay, because it's important for us. So the seasonal component, what is it? It's a fluctuation observed during the year, okay? During the year, which is very important. So it could be each day, each week, each month, each quarter, but you cannot seasonally adjust a yearly time series. It doesn't make sense, okay? Because the seasonal component is an intra-year movement. So it's a fluctuation that appears to repeat on a more or less regular basis from one year to the other. So it's a periodic, somehow it's a periodic component. I do not say a periodic component because periodic in mathematics has a very clear definition. It's constant and repeat exactly every year, okay? So it's not exactly, but it repeats itself from one year to the other. So it includes all the repetitive, predictable fluctuation in socioeconomic data. I mean, people are taking they go to holidays during summer. That's it. You can do what you want. That's it. So it's every year people go, except if you have a crisis like the COVID. Usually they are very regular. You have the school calendar, which is very clear also. You have a lot of things. You have your own celebrations. For example, for us, Christmas is a very, very important thing. It's every year. That's it. It's the 25th of December. There's nothing you can change. Okay? It's this date. Perhaps the amplitude of the phenomena can change, but not the phenomena. You will still have a peak in the trade series in France in December. That's life. This is seasonality. Okay? So I'm saying that, but because in general, the seasonality exists, it's clear, but it can vary from one year to the other. It can be more and more important or less important. It can vary. Even if you have in mind that on average, on a complete year, the seasonality will vanish. Okay. If you have more holidays in summer, you have less holidays in winter. Okay, something like that. You have some kind of compensation. But you must have in mind that the seasonal component may vary from year to year with time. What are the causes of seasonality? They are, of course, the first causes of seasonality is the climate. Seasonality is basically due to a variation of the weather and climate That's why we call it seasonality. It's linked to the seasons. Okay, it's clear. I mean, in agriculture, do not forget that it's coming. In the old days, the economy was agriculture. That's it. So they were used to the seasons, and they knew exactly what will happen. Okay, they knew exactly when to do the crops and so on. So you have in agriculture, it's clear. In the consumption of electricity, it's clear also, heating, cooling. And you have other causes of seasonality. For example, a link between the seasonality and institutions, which are due to the social habits and practice or even to administrative rules. For example, the effects of Christmas or Ramadan on the retail trade, or Diwali or Chinese New Year, the effect of the fiscal year on some financial variable, the effect of the academic calendar, and so on. So all these effects, which are also sometimes linked to the seasons. You can do what you want, but Christmas is always the 25th of December. So for France, it's always in winter. Okay, you can do what you want. It's linked to the season also. Okay. But the event itself is not linked to the season. It appears to be linked to the season because of the situation of France. But in Australia, they celebrate Christmas and it's in summer. Okay. So it's but you always have links. Okay. And you have indirect seasonality, which are due to the seasonality that affects other sectors. Let me give you an example. If you have in mind Christmas or a big event like Ramadan, people are used to, for Christmas, to buy toys for the children, okay? But these toys must have been produced. So Christmas will induce a seasonal component in the production of toys, perhaps a few months before, okay? But the toys have to be created and designed. So Christmas in December might induce a seasonal component in, I say, for example, March of the previous year to define and design the new toys and so on. So you might have some difference in some imported seasonality in other sectors, okay? Another, it's not seasonal component, but for example, calendar effects. Let us take the example of births. Okay, the nature is the nature, so there's no reason why you will have less births a Sunday than a Monday. It just comes when it comes. Okay, and the nature does not have a calendar in mind. Okay, just okay, if it's time, it's time. So it could be a Monday. It should be, I mean, the day should have no importance in that. But if you have a look to the births by day, you will say that you have less births during the weekend. At least in France. I don't know for the other countries, but I would say for most of the European or Western countries, it's the same case. So you have less births during Saturday and Sunday. So you might have two interpretations about that. The first one is that because you have less people, less doctors, less nurses during the weekend, they provoke the birth just before or postpone it to the next Monday. It could be one interpretation. The second interpretation could be that the administrative process is delayed because you do not have any administrative people during the weekend, so the administrative process is delayed to the Monday. And so you might have a conjunction of the two phenomena, you know. So sometimes you have the habits, the administrative rules that are going to import a seasonal component in a time series which has no seasonal component by definition. You see what I mean? Yeah. So you have to know your time series if you want to do a good adjustment, a good modeling and good adjustment. So calendar effects, I will discuss that. So for example, seasonality, I told you is not the only calendar effect. I say seasonality is a calendar effect because it's linked to the seasons. And you record all the data now according to the Gregorian calendar, which is a solar calendar. So which is linked to the motion of the Earth around the sun. So which is deeply linked to the seasons. So seasonality is a calendar effect. But this is usually we do not, when you say calendar effect, we do not mean seasonal component. We mean something different. Sorry. The training day over weekend day effect, which is linked to the daily composition of the month or the quarter, and that is not constant over time. We will discuss that later, okay? And moving holidays, I already told you, and I quote more moving holidays, Easter, Ramadan, Chinese New Year, Diwali, Pesach, and so on. There's a lot of different also. I would be happy to learn more. Probably you have some moving holidays in your countries, but I would be happy to know. The irregular component is a residual component, okay? So you have a residual and random fluctuation that cannot be attributed to the other systematic component, okay? So it's just the fact that you model the trend cycle, you have a clear definition of a seasonal component, of a calendar effect, and everything else is in the irregular. Doesn't mean it's completely random. It means just that it's not in the other component. So I got some example, and strikes, floods, storms, war for very unexpected events, errors in the measure of the variable itself, for example, due to data collection and treatment, the end of financial program, a change in the definition, and so on. So you might have this kind of event. What is the COVID crisis? Should it be in the irregular component or not? That's a question. It's still a question. We do not have data enough to answer completely to the question. For me, of course, it's a downturn in the economy. And so for me, it's a turning point. And because it's a turning point, it should be in the trend cycle. It should be in the cycle. Okay. But I have some friends who are saying, wait and see. I don't know exactly what it is. Okay. So, but for me, this is, I do not know exactly the form of a component of the impact, but what I know is that it's a downturn in the economy, and so this is in the cycle and not in the irregular. We will discuss that, of course, for your time series, more with a monthly time series than with a quarterly time series. So what is the seasonally adjusted series? Keep that in mind. By definition, the seasonally adjusted series is logically defined as the raw series from which you remove the seasonal component. But it has been extended, this definition, to the calendar effects. So you might have a calendar adjusted series, which is the series from which you have removed the calendar effects, so the trading day effects and the moving holiday effect. And you might have a seasonally and working day adjusted series, which is the series from which you remove the seasonal component, the trading day component, and the moving holiday component. Usually, this is the series you want to publish. And we will see later how we can estimate all these components. So you have to to be aware that seasonal adjustment is not a very simple process. It's something. It's like a medicine. Okay, you will apply a medicine to a time series to correct from things. Okay, you think that you should remove this kind of thing, so you apply a medicine on the time series. If you do not have a seasonal component and you apply the medicine, you might have very serious counter effects, side effects. So you should seasonally adjust a time series or a working day adjust a time series only when there is a clear statistical evidence and economic interpretation of a seasonal or calendar effect. If you have a doubt, if you have no rationale behind, you should not do it. In some occasion, for example, you might have statistical tests that are going to tell you that, that you have a calendar effect. But sometimes it's stupid. You cannot. And sometimes you have. Let me tell you two examples. The first one, I was working with my friends from Tunisia. It was the first time I was working with them, and I was using my packages as usual. So the first time we seasonally adjust a time series, because JDemetra Plus comes from the Catholic Western world, you have embedded inside Easter effect. But I mean, Easter for Indonesian people, for example, yes, you probably have some Catholics in Indonesia, but Easter is not celebrated. It has no impact on the economy. So for you, it would be insane to have an Easter effect, okay? So I seasonally adjust the Tunisian time series, which is a Muslim country, as you know. And I saw a clear Easter effect. So I look at the series and I was confused. So I told to my friends, I'm sorry, I'm stupid. I should not have put the Easter effect. I'm sorry, really, I'm ashamed, okay? And they were smiling. So I thought at the beginning they were just pulling my legs. They were just kidding with me. But not. They were smiling, and one of them told me, Dominique, no, we have in this series, we have a very strong Easter effect. So I said, come on, Adnan, it's not possible. You are a Muslim country. You never celebrate Easter. He said, no, we never celebrate Easter, but you do. And the series you are looking at the moment are the hotel nights. So the tourism. It was a series from the tourism sector. And so he told, yes, we do not have any Easter effect. But when it is Easter in Europe, you take holidays and you go to Tunisia. So we have a huge Easter effect in our time series. And he was right, of course. But behind, you have a clear economic interpretation of a calendar effect. So you can justify that you are going to correct from Easter. Another example, completely the opposite. At this time, I was used to run the more complex model to see what's happening. It was a stupid thing, but I did it, okay? And most of the people are doing that. And so I discovered once a huge Easter effect in the production of concrete in France. In the production of concrete, a huge Easter effect. It was a complete nonsense. And a positive one. You could imagine, for example, okay, I have a negative one because the business are closed, the factories are closed during the holidays, the Easter holidays, but it was not the case. It was a very positive impact. So it was a completely nonsense. It was a statistical artifact. So I should not correct from an Easter effect in this time series, even if the statistical test is very significant. It's just stupid. So do not do it, okay? So do not keep that in mind. This is the difficulty of seasonal adjustment. You cannot perform a good work, a good job, if you do not have in mind your time series. You must know how the time series is built, how it has been computed, what is the economic rationale behind. If you do not do that, you will get probably bad results. I will comment that later, again and again. And so if you do an inappropriate statistical treatment, you might have side effects. So think about it, okay? So now I define all the components, okay? I have my Lego game, and I have here a trend cycle, here a seasonal component, here a trading day effect, here a moving holiday effect, here an outlier effect. I have all my components, and now how can I compose them? Do not remember that seasonal adjustment is an unobservable component model. So you do not observe the trend cycle. You do not observe the seasonal component. You can see it. You can see it on the graph, for example, but you do not measure it. You do not observe it, okay? So you must see how you can compose your model. So you have, for example, here you have an example of a decomposition from a STL program. You can find it in A. In particular, I should change in A or S+, which was an old version of A. So here you see in the top panel, you have seasonally the raw data. Second panel, you have a trend. Third panel, the cycle, the seasonal component, and the irregular. So you can have this kind of graph. Okay. So how can you identify the components? To be simple at the beginning, you are going to say that you can decompose a time series in three main components: the trend cycle, TC, trend cycle, the seasonal effect, S, and the irregular fluctuation, I, okay? And the raw data, you can express them as a function of those components. So it's a function F of these three components. Usually, and now you have to think about the F function. What is the shape of this function? You have several aggregating functions, much more than we can think, but most frequently, the most used decomposition are the additive decomposition and multiplicative decomposition. So the additive decomposition is very simple. You look at the sum of the components. So here I did not separate trend. I did separate trend and cycle, but you should not. I should not do that. So trends, I will correct that. Trend cycle plus seasonal plus irregular, or trend cycle multiplied by seasonal multiplied by irregular. If you have a multiplicative model, and if you have only positive figures, you can derive what we call a log additive model, which is, in fact, you take the logarithm of a product, and so it gives you the sum of a logarithm, okay? And you can add as many outliers, as many components as you want. So you have these two basic models that are implemented in JD+, which are the additive, multiplicative, and log additive model. We will see that later, okay? And you might have more components. Okay. Let me give you an example, a theoretical example. Here I have a linear trend, and I have a seasonal component of period 2, very constant, okay, no problem. If I do the sum of the two, I will have this additive model, okay? So it's very Nothing changes. Okay. On the right, you have the multiplicative model. So you multiply the trend by the seasonal component. You will find this kind of time series. So it seems that the seasonal component is moving with time. And in fact, it's not moving with time. You see, the seasonal component is constant. But this is the decomposition model that gives you the impression that the seasonal component, when the trend increases, the seasonal component increases. And when the trend decreases, the seasonal component decreases. So in this case, and you will see that it's not so difficult, you have a multiplicative model. In this case, you have an additive model. And you will see that if you look at a graph, I would say that in 95% of the cases, you will detect immediately the model. Of course, you have statistical tests to do that, okay? So you can just rely on the test or not, but don't worry, you will have help to determine the kind of model, okay? So now, okay, so it was a soft talk up to now. Nothing very serious. I was just talking, okay? Telling stories, telling definitions, but apparently nothing serious. So now, let us think about what I said, okay? In fact, we have a problem, a big problem. So if you look at the seasonal adjustment problem, you have an observed component model, and you must estimate at least one of the three components, which is, for example, the seasonal component, but you might also want to estimate the trend cycle on the irregular. So to be honest, you have one equation, just one equation, and you have three or more unknowns. So from the mathematical point of view, you have an infinity of solutions. Okay, it's clear. You cannot solve this equation. But when I use JDemetra, or when I use any computer program for seasonal adjustment, if I push the button, I have one result, only one result. When I have an infinity of solutions from a mathematical point of view. So the solution itself, the real solution does not exist. It cannot exist, okay? So a time series does not have one trend. It might have several trends, estimated trends, okay? You assume that you have a virtual trend, but any methods will give you a different trend. Let me give you two quotations. It's very disturbing. I told you that I gave you definition of a trend cycle, but in fact, I didn't give any definition. It was just words, okay? If I discovered this quotation when I was younger, so I was completely puzzled by that. I was used to read the textbooks, of course, and so I read the Sir Kendall, the book on time series, wonderful book, wonderful. And I discovered this quotation. The essential idea of trend is that it shall be smooth. Okay, I do not know exactly from the mathematical point of view what means smooth, but it's clear that it has to be smooth. Okay, so now I discover a few years later another quotation from a huge statistician, Andrew Harvey. And the quotation is the following: there is no fundamental reason for why a trend should be smooth. So as a student, and today I'm less puzzled, but I'm still a bit puzzled, you have two huge statisticians that are exactly saying the opposite. So one is saying the essential idea is that it should be smooth, and the other, there is no fundamental reason why it should be smooth. And these statisticians are good. They are not stupid guys. They are good. So it means that this conception of the economy here, when you say a trend is smooth, and the trace is not smooth, you have different conception of the economy. Basically, you have on one side Keynesianism and the other side monetarism. You have the two sides. And this conception of the economy, these different definitions, if I can say so, these differences are present in the various methods and software, and in particular in Tramoseats and X13, the two main methods. I would say that Tramoseats is a method very close to Andrew Harvey, and X11, X12, X13 is a method very close to Sir Kendall. So you do have two conceptions of the economy, and they do not estimate the same thing, and therefore, because they are not based on the same hypothesis, and therefore they are going to produce different results. So, okay, it's disturbing, but that's life. Okay, so now think about what I said just before. I told you that the big difference between time series and survey data is the number of observations. You have very few observations. Even with a series of 20 years of monthly data, you will have only 240 observations, only. I mean, it's with quotes, of course, it's 20 years of work, so it's not only, but for a quarterly series, 20 years, 80 observations. So if you want to do some statistical analysis, you must do some hypothesis on the component. I will show you later examples. So you have here two hypotheses on the trend side of the trend. So if you follow one, you will have one decomposition. If you follow the other, you will have another decomposition. The good point is that in 95% of the cases, the decomposition are very close to each other. So you do not have any problem. But a very important consequence for an institute is that you have to choose one method and you have to stick on the method. You cannot, for any reason, you should not move from one method to the other. It's not because, for example, you will like more the results of Tramoseats than the results of X13, that you should go to Tramoseats. And because if you do so, next time, if X13 is going to give you a result that you like more, you will go back to X13. You see, you cannot do that. You have to choose one method and stay with this method. It's at the beginning, I say you must have a seasonal adjustment policy, and the institute has to choose one method. I don't care. The choice is yours, okay? It's not my business. Either you choose Tramoseats, either you choose X13. Usually most of the people choose X13, except in Europe where we are 50-50 between Tramoseats and X13. I don't care. You choose the one you want. Okay, the IMF choose X13. I can tell you France, Germany, United Kingdom, they are X13. The Dutch people are X13. And after you have Spain, Italy, a lot of Eastern countries are Tramoseats. So it doesn't matter. Nobody cares about that because it has a lot of implications for you. It's difficult to be good in the two methods because they are very different. You can, but it takes a lot of time and a lot of resources. And an institute has to stick on its training program. So you choose something, this is this method, now I can implement this method in my production system, I can give the training to my people and so on. This is a policy, a global policy. You cannot change, okay? Because it will cost you a lot. If you change from one one software to the other, the output will change, so you will have to change your production system. You cannot afford this kind of thing. It's too costly for an institute, so you choose one, the one you want, and you stick on it. Okay? So it's not so soft talk, what I'm saying this morning. Okay. So let me explain you the difference between the two approaches, Kendall, which is close to X13, and Harvey, which is close to thermocytes, the two main methods. In fact, here you are in the conflict, if I can say so, the opposition between parametric methods and non-parametric methods. So the nature of the hypothesis you are going to make on the series or on the components generates different methods and softwares to do seasonal adjustment. The main distinction is the following. Either you are parametric, so if you are parametric, you will assume that the series or the components can be modeled with simple mathematical function depending on a small number of parameters. And your problem will be then to estimate the parameters. Okay, I will give you an example. In the non-parametric world, you will say that no, it's not possible. You cannot fit a simple model to a time series because reality is more complex than that. And it's not possible. So you are not going to do some direct adjustment. You are going to say, okay, only general assumption of the series. And you will define after a decomposition model. I will illustrate that this week. So two basic and simple examples. It's the first, I guess the first equation I put in my slides. It's not a big equation, but I take regression methods. Nobody is using regression methods nowadays, but let us have a look to them. You are going to do very strong hypotheses. So for example, you say, okay, I have a trend cycle, I have a seasonality, and I have an irregular. I will model each of them. So I will say, my trend cycle is a straight line. It's a linear component. I have a constant seasonality. Constant seasonality means that each quarter, I have a seasonal component, so each quarter is different from each other, okay? But the Q1 of 1 year is equivalent to the Q1 in the second year, third year, and so on. Doesn't depend of time. So I will have what we call the Bisbalo model. You remember I talked about Bisbalo just a few minutes ago when I said it was the first model in the literature by a Dutch economist. And this is the model he used. So he said, this is a straight line, AT plus B, okay? I have a line, okay? And here I have my seasonal component, which is constant through time, which depends only on the quarter. I have here a quarterly series. So I have 4 seasonal component coefficients. The one for I equal to 1 for the first quarter, 2 for the second, and so on. Okay. And after I have the right noise. So I did, and now what I want to do is just to estimate A, B, and the 4 alpha, and also perhaps the variance of the noise. If I want to do that, I still have an infinity of solutions. So even if I precise every component, I still have an infinity of solutions. Let me explain you in simple terms what is happening here. Let us imagine you are on the beach with your children. And for example, your son comes to you with a bucket of sand, okay, and tells you, oh, Mom, Dad, I would like that you help me to do something with the sand, some forms with the sand. So you say, okay, no problem. What do you want to do? Oh, I would like to do a ball, a square, and a star. So you see, you define exactly the form of the components. I want a ball. It's very clear what a ball is. I want a square, a cube, for example. I want a cube. So it's very clear what a cube is. No problem of definition. And I want to have a star. Or you say, okay, a star, I have a problem. Do you want 6 or 5 branches? Or 8 branches or whatever. Oh no, I want 5 branches. So it's clear, the form of components. So you have a sand, you have to divide the sand in 3 parts, and the definition and the form of the parts is clear. You exactly have this kind of model. But if you think about it a few seconds, you will say, well, something is wrong. I still have an infinity of decomposition because my son didn't tell me the size of a ball. Is it a big ball, a small ball? Is it a big cube, a small cube, a huge star, a small star? So you still have an infinity of decomposition. And that's the problem with all these methods. Even if you specify everything, you must choose a solution. And this is what I wanted to stress today. It's very, very uncomfortable for you, very disturbing. But, you know, yesterday, I pushed on the button and I received in a few seconds the 500 decomposition of my 500 time series and 1 decomposition per series. And I'm telling you that's not possible. You have, for each series, you have an infinity of decomposition. So how the software is doing the choice? And by the way, it's very often a very good choice. So how is it doing this kind of thing? This is the objective of the parameters. When I told you yesterday, I'm going to choose the RSA1 set of parameters. When I say that, I say to the software, this is the kind of decomposition I want. This is the model I want. And I'm going in a very detail. The set of parameters is going to point out one solution only. So this is very important to think about the model. Each set of parameters corresponds to the specification of a model. And we will discuss that together for the next days. Don't worry about what I'm saying. At the end of the day, it's a good story. I mean, it's a feel-good story. At the end of the day, you will know a lot of things about seasonal adjustment. You will know how to seasonally adjust your series. But at this beginning, it's a bit disturbing because I'm telling you, yes, there's an infinity of solutions. So the setting of the parameters is very important because you are going to specify your models, in fact, your precise model. Okay. So the second, I told you, you have 2 big things. So, for example, the regression methods. And you have the others. It's basically Tramoseats is doing not this kind of thing because this kind of regression method do not work very well. So it's using another linear model, which is called regression linear model, which is called ARIMA modeling. I will tell you about it perhaps Friday, perhaps, yeah, or next week, I will see. So the other way are moving averages. Moving averages, this is X13, basically X13. It's easier to explain because you know what a moving average is. You are used to compute them. So we will do that tomorrow, I guess, or the day after. We will do a simple exercise with Excel to compute and to understand moving averages. you are going to do very weak hypothesis. So for example, you are going to say, I have my series as a locally polynomial trend. So it's smooth because a polynomial is smooth, okay? So it will be of degree 2, degree 3, degree 1, but small degree, okay? And I will say the same thing, my seasonality is not really constant, but it's locally a linear or polynomial seasonality. So I will just say that, okay? And so you do not have any equation for the components, and therefore this equation does not depend on parameters. I have no A, B, alpha, Y to compute. I will compute my trend. I will just compute it, but it doesn't depend, this trend cycle does not depend on parameters. So I have what we call the non-parametric methods. Usually the one which are based on moving average is what I call the X11 family. So it's just a succession of variants of a software. X11, if you remember, it was in my list of important dates. It was in 1958, je crois. The first X11 was born before, but X11 was in, you had those X0, X1, X2, and so on. X11 dates from 58. After you have X11 ARIMA, X12 ARIMA, X13 ARIMA seeds, and so on. But don't worry about the name. Myself, sometimes I'm mixing the numbers. So I would say X12, X13, X11. There's a difference, but it's the same family. Okay, they are twins. Basically, they are twins. And you have other methods. So what I think, and it's still time to change, is that we are going to focus during the training and the next training on on this family, X13, X12, X11, okay? I'm not going to talk a lot about thermoseats, which is a good software too. But my understanding is that we go with X12 or X13. So if it's not the case, you still have time, perhaps up to tomorrow, to tell me, no, Dominique, we go to thermoseats, okay? And I will change the slides, okay? My feeling is the following on the choice of a software. The two are good, okay? There's no doubt about that. Of course, if I discuss with my Spanish friends or Italian friends, they prefer thermoseats. I prefer X12. It's just a question of taste. It's just a question of philosophy. It's not there's no order, okay? And the point I know is that I would consider, if I made the comparison with a car. I told you that you will be able to drive the car, but perhaps not to fix the engine if you have a problem for seasonal adjustment. And here, if I take the same idea of cars, I would say that X12 is a 4x4 and the thermoseats is a Ferrari. So be careful. A Ferrari is a bit more difficult to drive, to manage. You cannot drive a Ferrari as you drive a 4x4. In particular, some roads are not good for a Ferrari. And for a 4x4, you have no problem. Okay? You can, so I'm feel more comfortable with X11, but I know it for years. I'm fluent in X11. I'm not fluent in thermoseats, okay? And so, and it's easier to manage, definitely. Definitely, because if you have a problem with thermocytes, you must know exactly what is the theory behind. And it's not easy. But anyway, tell me, okay, Siska, if you want to go to thermocytes, but we will study a bit thermocytes during the more advanced course. We will spend some time on it because you must know it. It's important also to do a good adjustment. You must know ARIMA modeling. Okay, so I'm done for the presentation. Yeah, I'm done. Wonderful. 1 hour and a half. So we can do a short break, and after we go back to GD Plus.
Yes.
And we work and we practice. I have a lot of small exercise to give to people just to feel comfortable with the software. Okay? So if you have any question, I understand this is not an easy talk. It was really a soft talk, no mathematics, nothing, but a lot of information behind, and sometimes a lot of disturbing information. But we will illustrate that during the next days. So it will come. You will discover what I mean when you do not have one solution. I will show you several solutions for the same problem. You will show me several solutions for the same problem. So if you have any question, please feel free to send them through the chat box, and I will be happy to try to answer to them. Okay?
Okay. After the short break, there's one question from Agus, but you can answer it later after the short break.
So Agus is there? No, he's not there. No question?
One question from Agus.
Agus is coming again.
Actually, you have explained it at the later stage, but good if you can also repeat the answers.
I'm not sure I got you, Agus.
There's the chat.
I think this is regarding the X12, X13, and the method. You said we should choose one of them.
Yeah, I mean, this is an official decision. So you choose it. You tell me by mail which one, but I'm pretty sure it's 12 because we already worked last year with Siska and that, so I know this is X12. It was just a question. I mean,
yeah, Fatura is correct. The question is, we should take when we first choose one of them. And actually, you have and my question, you have explained this, and so more or less, for Ramos, we must know the related to the time series, yeah. So it's more difficult to manage. So I think it's good if you can again explain to us. Thank you.
I'm not sure I got you, Auguste. The sound was not very clear. So what was your question? Siska, did you understand the question?
Yeah, actually you already explained during the first session, and then Agus wants you to, if you can, re-explain again what is the consideration we should take the first time when we choose the method. So how to consider that? How we choose the method, the correct method.
How to choose the method?
Yes.
Yeah.
Yes.
I mean, it just for most of the countries, I know, for example, the Western countries, European countries, the choice was a choice of historical choice. So, for example, as I told you, X11 is dates from the 50s, 60s. So it arrived very soon in the National Institute of Statistics, the old European Statistical Institute. For example, it arrived very soon in France, very soon in England, very soon in Germany. So they were used to seasonally adjust figure in the 70s already with this software. So after to change was not a real question. Spain has the choice because Tramosis is a Spanish methodology. It has been developed by the National Bank of Spain, by Agustin Maraval, I would say in the 80s. And Spain moved to Tramosis, and they are using Tramosis. But once again, it's a national choice. They decided to go to Tramosis. After we are in the 90s. In the 90s, you have all the Eastern countries that are coming, okay? And they had a choice between X12 and Tramosis. It turns out that at that time, at the end, in the 90s, Eurostat was more Tramosis. And Demetra, if you remember, I told you the first package Demetra developed by Eurostat was heavily Tramosis based. But that's life. I mean, why not? Okay. So Western country, Eastern countries, sorry, usually choose Tramosis. So in Lithuania, in Latvia, in Poland, in a lot of countries are using Tramosis. So it's not a choice of method. I would say that anyway. Eastern countries usually have a huge mathematical background. When they hire people from the university, they are mathematicians, okay? So most of the people are really trained in mathematics. And so for them, it's more natural to use Tramosis because behind you have a clear and sound methodology, mathematical methodology. In the non-parametric world, it's a bit more difficult, probably. You have no parameters, so you have no confidence intervals, you have no all these things. But the choice is not really this kind of choice. It's just a question of you choose one and you stick on one. The point is that you must have technical background, more technical background if you use Tramosis than if you use X12. It could go very worse with Tramosis. It's very scarce, it goes worse, bad, very bad with X12. So it's your choice. After you have to know that when you choose something, after you have to develop all the policy, so the training policy, the production system, all the IT problems linked to the production system. And all these things are very expensive, time consuming and expensive. And so you are not going to change. I mean, you can change, but it will be costly. Okay. So that's, there's no, I would say that in the world, perhaps 80%, 70, 80% of the statistical institute are using X12 and 20 or 30% are using Tramosis. I do not know the figures, real figures. This is my estimate. There's a lot of documentation on X12, so you can learn it very easily. and it's easier. It's easier to manage at the beginning, at least. So my advice, if you want one, is just my history. So go with X12. It's easier. But for example, if Agustin Maraval would be there, he would kill me, because he will say, of course, thrombosis is much better. But it's not, yeah. Well, we will discuss that. But for me, I think X12 is a sound choice for me. But you might have another idea, and I'm good with that. If you say, no, we prefer thrombocytes because thrombocytes, I can have confidence intervals, I can have a lot of tests and things like that. Okay, but it's not an answer, but this is your choice. I mean, it's a political choice. So I will do what you want, by the way. You are the boss.
Okay. Is it clear, Pak Agus?
No, it's not clear.
Okay.
I know that. I know my answer is not clear. I know that.
Yeah, I have a much better idea now. So I think I
The
would
easy one.
suggest
With the easy one.
we go with the X11 as well as
So we will. I mean, I cannot at this moment. I cannot argue more. You know, I cannot give you. When we will study in the next course, when we will study thrombocytes, I will explain you how it works, and you will understand what I mean by it's probably a bit more difficult to manage. You must have a degree in statistics, a university degree in statistics to manage thrombocytes. And you do not need to have that to manage X12. So you will tell me, but I consider more or less that it's done, but you will tell me. Other questions?
No
So
more in the chat room.
Sorry?
Just small question that
There is no.
both methods are available in JDemetra, yeah?
Of course,
You
yeah.
mentioned before, okay.
Yeah. I will show you again. We already had a quick look on that yesterday, but I will show you. And we will experiment the two, just to show you that they usually give very similar methods. The problem is not when a similar results. The problem when you use a method, the problem is not to use it on the everyday basis. It's just what happens when something is going wrong. How can you fix it? This is the only problem. And my understanding is that it's much more difficult to fix thrombocytes than to fix X12. So we will, but we will see that. It's an exercise we will do during the week to compare the results of the two methods. Okay. So is
Then
there
we can have a short break.
A short break now? Okay. So I will go to bed and be back in.
Coffee break.
So see you in how much time, Siska?
And I will do the polling. Yeah?
How much time you want? At what time do you start again?
10 minutes,
15
maybe?
minutes, Siska.
Okay.
15 minutes,
Wonderful.
okay.
10 minutes. It's 50. So, okay.
15.
Okay.
15 minutes, yeah.
Okay. Wonderful.
And I will watch the polls.
But Tet is not a Chinese New Year? Fatur? Ah, he left, okay.
I'm still opening the polling. because only 15 participants responded to the questions.
We cannot respond to everything. We cannot answer to the last question because we did not. I'm going to see that with them now. But I thought that the Tet for Vietnam, I guess, is the same date than the Chinese New Year. It's not the same date, the Tet.
Here, I think because they have like 2 weeks. Like
yes,
in Indonesia, we have also Chinese New Year.
But this is the same date than the Chinese New Year, I guess, no?
Yeah, the same period, yeah. But only in Vietnam. Shall we start or we wait?
It's up to you.
I don't know if participant already here yet or not. Already come back from the from the coffee break. Do you want to discuss the polling for the answers or?
Oh, you want me to discuss the answers?
Maybe.
So, can you remind me the questions? Because I do not have any more the pool. So,
okay.
the first question, oh yeah. So why do not we separate the trend and the cycle in seasonal adjustment? Both answers are correct. I mean, it's not the objective of seasonal adjustment. Remember that seasonal adjustment is the adjustment of seasonality. So it's not the decomposition in trend, not the estimation of a cycle on the trend. Second thing is, by the way, often series are too short to make the distinction of the two, and so the two are okay. Okay, so everyone is. I mean, it's a good question because everyone is true. What moving holiday do you celebrate in your country? To be honest, I don't know. I can tell you for France, but it's irrelevant here. So I thought, but I'm sure of that the Tet has the same date than the Chinese New Year. It's the same thing, not the same celebration. I understand, not the same festival, but it's the same period, definitely. So the bad point is that you do not have this calendar in JD+, but we will discuss that later. Okay. How can we detect seasonality? You cannot answer to this question because I didn't give you the answer yet. But by the way, you are right with both with both things. Graphs and statistical tests are important to detect the seasonal component. One very you should look at your data always. I mean, at least once a year, you should understand, you should look at the graph of your series. I understand it could be a huge work because, for example, for trade statistics, a byproduct, it could be a lot of time series. But at least for the most important series, you must have a look to the data. And we will do that. And I'm pretty sure I didn't do it up to now, but we will do that this week. And I'm pretty sure we will see some things. We will see some disturbing things. You always have problems in databases, and we will see that. Okay, so the answers, we will see the last one probably now and tomorrow and the day after. Okay, so other questions? No? If you have, I see that we have free chat. Let me, yes, ready, I'm ready. Everyone is ready. Okay, wonderful. So may I start the work with JD+ now? Everyone is there? Yeah? I can go, Siska? So I will share my screen again, and I'm going to open JD+. So if you can do so, do the same for me, with me. Let me, yes, I'm ready. Okay, still low. Okay, so do the same, open JD+, and just open it. I will show you a couple of new things. Oh, I made something wrong. Oh, sorry, I did something stupid. Do you hear me? No?
Yes, yes.
Yes, I can hear you.
Yeah, we can hear you and also your monitor there.
Okay, so, but, okay, it will be okay.
Okay, Dominique.
Okay, so let me, so I open JD+. So you open it. Okay, so I'm used to, first thing, your screen might have changed because when you use JDemetra+, JDemetra is going to adapt to your to the way you are using it. So it's you can change the window size, you can do a lot of things, and JD+ is going to adapt. So probably now we might have different screens between all the participants. Okay, you might have. So anyway, now the first thing is to read the data. I'm used to say that a good statistician should be lazy. It means that you should not do things that are not important to your work. And for example, when you are doing seasonal adjustment, it's not very interesting to lose time to look for the file and things like that. So a good software should give you a lot of tips to save time. For example, here, if I want to read the same files than I read yesterday, and I will, I have just to say file. You see, I will perhaps try to increase the size. So up and plus, where is my plus? It's there. Okay, so I will try to increase the size, yeah. So look, here, yesterday we saw, don't do it. Yesterday we saw that to open the file, I go to spreadsheet and so on, open and so on, okay? I'm not going to do that because I already did. So I will go to file, open recent, and here you should have the two files we read yesterday. So you just have to click on one of them and to do it again for the other one. Open recent, and you open the second one. okay? And now they are here. Okay, so this is the first thing I wanted to give you today. It's an interesting tip because you won't have to redo all the work with the Explorer and so on. Okay, so we can do it. Okay, so now if you remember well, we can do, you tell me if something is wrong, okay? So you can open files, for example, and here for the exports, you see that we have a lot of things, and in particular at the end, we have basically 100 products, roughly 100. And do we have, we do not have a complete exports. Too bad. We do not have a total. Yes, we have a total. But what is the total? What do you mean by total? In this case, Siska, what do you mean by total?
Export and import from each products.
So you make the difference. Okay, you do not have the exports and the imports total for the
No, I don't agree.
It doesn't matter. Doesn't matter. I wanted to compare the series, but it doesn't matter. I will. No, it's okay. It's okay. I will do that on another. For example, if I want to compare, let us imagine that I want to make a graph of the 8 countries, the GDP of the 8 countries. Okay, so it's not very difficult to do that. Let me show you. I will open Tool, Container. So I give you some time to do the same. Tools, Container, Chart. So you open a window. So I have my window now, a new window. And the point is that I do not have indices, so I cannot completely compare them because they have not the same size. But anyway, let us imagine that we try for Brunei, for example, to compare manufacturing. So I have manufacturing and construction. Perhaps it's a nonsense. It looks to be a nonsense, but where is my... oh, what happens? I should... Sorry, it's the... Oh. Sorry, I'm lost with a Zoom because it doesn't work, the menus for me. I apologize. I cannot. I will find it somewhere. Yeah, sorry. So it was not a good idea to compare the two graphs because they are not expressed as indexes. But anyway, you see that you can put several graphs and compare graphs with that. Okay. So what I want to do now is just to look. I will take one series only. I will take one series, for example, Vietnam. Why not Vietnam? Okay. So I will take the first one, GDP in current prices. So if I double click on it, I do have the series. Okay. And now, of course, if I look to this graph, I will see immediately that I do have a seasonal component. But in some occasion, it's not so easy to see that. So we will rely on statistical tests. So let me show you a couple of things to help you to do the job. So first, if you remember yesterday, I told you that to perform a seasonal adjustment, you will go to statistical method. Let me know if something is wrong, okay? Just go to the chat and say stop, okay? Seasonal adjustment, multiprocessing new. I will I will do only for the, let us take all the GDP, okay? So the second Excel file. Oh no, I don't do that, sorry. Don't do it now. As I told you, the first thing is to tell to GD Plus which method you are going to use. So here, if I click on this part, if you remember, you have the options, the specification, the default specification for thermocytes and the default specification for X13. As I told you, I'm going to use the ASA1 specification. So I select it and I have it here. I should do it before I read the data. If I put the data here and I didn't change the specification, I will use the old one specification. So let me now show you something else. If I want to be sure that I am going to use this specification for the moment, I can change the default of JD+. So let me show you, for example, if you go to Tools, Options, you will have access to a lot of options of JD+. For example, you will see that you will have, for Demetra, you will have some things on the user interface, so you can change the colors, you can change a lot of things. You can specify the number of years you want to plot. You can change, you see you can change the colors, things like that. So I'm not going to change them. You can do in statistics, for example, here it's important because here you can change the default method. So for me here, you see, I will use the zoom. You see that for me, I have chosen X13 RSA5C as the default method. You should have something different based on thermocytes. I guess it's TS RSA full, which is the default specification for GD Plus when you just download it. But here you can change it. You see, I can change my default specification. And I can put, if I want, RSA1 for the sake of a training. From time to time, we are going to change it, but you can put it. If you do that, the next time you are going to open GD Plus, you will see this kind of specification when you want to do seasonal adjustment. So you can do it, okay? So now I will have this thing. Sorry, so I will, okay. Is it okay? Yeah, no question?
Yes, okay.
So let us take, for example, all the file of the GDP Excel file. So I put it, I drag and drop the data in the SR processing window. So I have basically 200 time series, okay? So it's starting from Vietnam to, I don't know why Vietnam. Beware, we might have different orders. I don't know why it's ordered. You can change the order, I guess, if you. Yes, it's pity because sorry, I made something different. I don't know what happened, but I do not have a real order now. You see where I have lost the order between current prices and constant prices. Anyway, I'm sorry for that. You should have something different in your, I don't know what's happening. Let me change. Perhaps it just, let me do it again. So if I do it again, I will have a new window, SR processing 2. Here, I will change it. And I will put it, I hope it will be, yeah, I have the real order now. So we should have the same order now. Okay, so I have 200 time series. So if I want to run it, I just click on the green arrow. So we already did that yesterday. So it's not new for you, even just some kind of dry run. And now let us see, we want to see if in Vietnam, we were in Vietnam just before. So I go to the end, Vietnam. So I take the current prices. So if I click on the current prices, I have here the seasonal adjustment of a series. So everything is okay. This is not what I wanted to show you. I want to show you some things on the statistical test. Okay. If I want to know if my series has a real seasonal component, I will go to diagnostic. Do you see it? I will try to increase the size. So here you can see diagnostics. If I click on the plus sign, I will have seasonality test. And if I go here, you can do the seasonality test on a lot of different components. I will take the original series. Okay. So what does it mean? Original transformed series. It means if you look on the right, you see that the series has been log transformed. I will come back. In fact, if you go to the graph, you see that you have exactly the shape of a multiplicative model. You see that you have quite a linear trend cycle, and it seems that the seasonal component is increasing with the trend cycle, okay? So this is a multiplicative model. So it has been automatically detected by JDemetra, and you know that the series is going to be transformed, log transformed to use a multiplicative model. So here you see that it has been transformed, okay? So if you click on it, you will have all the results of a seasonality test. So here you have 6 different tests, statistical tests to detect for the presence of a seasonal component, and you have after all the detailed results after. So here you can see that the test for autocorrelation is positive, Friedman test is positive, all the tests performed are positive. Okay, so up to now, no difficulty. The series is very clear. So when you begin to see some contradiction between the tests, so someone are going to give you yes, the others no, the other uncertain. It means that usually it's basic common sense. If the seasonality tests do not agree, it means that the situation is not really clear. So you have to pay attention when the tests are contradictory. Of course, if you have 5 against 1, you will say, okay, it's seasonal, or you take the majority rule. But when it's not clear, it's usually because your series, you have a lot of noise or whatever, and the seasonality is difficult to detect. If it's difficult to detect, it will be, of course, difficult to estimate. So we might find this kind of thing during the week. I think that perhaps we will have this kind of thing on some products in the trade statistics. So we will see that later. So here you see that you have the tests are very clear. You have no problem in the detection of seasonal component. And by the way, the graph itself was really, really clear. Okay? Sorry, I have... it's not easy to deal with this Zoom. Anyway, okay? So now let me again try to comment this short graph. I love these two graphs. For me, these two graphs gives me most of the results of a seasonal adjustment. So what is, we will detail that later, but I will explain this graph. Of course, you see that you have 4 graphs. You have 1 graph for each quarter. So this is here, the dots are the estimation of a seasonal plus irregular. Okay, remember that our model is something like trend cycle plus seasonal plus irregular, or multiplied by seasonal multiplied by irregular, in this case, because it's a multiplicative model. So here, the dots are the estimation of seasonal multiplied by irregular. The blue curve is the estimation of a seasonal component. So you remove the irregular, okay? And the red line is the average, okay? It's the average. For example, if you want to test the significance of a seasonality, do we have a seasonal coefficient? In fact, the Fisher test will check between if there's a difference between the average. So it will check if there's a difference between this red line, this one, and this one. And it's clear that you have a difference between them, okay? At least between the Q1 and Q4. So your series is seasonal. The seasonal coefficient is the blue curve, estimated by X13. So you can see that your seasonal coefficient is slightly moving across time, okay? At least for the first quarter, second quarter, and last quarter. If you have a look to the left axis, you will see that it's between 0.75 and 1.30, which is expressed in percentage because it's a multiplicative model. So if you want to interpret this thing, the normal will be 1. So for example, the Q3 has no real seasonality. It's a normal thing. But the Q4 has a seasonal component around plus 30%, which is huge, okay? And the first quarter has a seasonal component, which is about minus 20%, 0.8, so it's minus 20%, okay? So when you look at this graph, you see a lot of things. You see first that you do not have, you have a multiplicative model because all these things are expressed in percentage. You will see that when we have an additive, you will have positive values and negative values, centers around 0. Here it's centered around 1. So it's a multiplicative model. I can see that the seasonal component is clear. I have Q4 is very high, Q1 is very low. So I have no doubt I have a seasonal component. You can see also that because with the dots, you have a seasonal plus irregular, you have very few difference between the blue curve, which is the seasonal component, and the dots, which is the seasonal and irregular, which means that you have very few irregular in your time series. Very, very few. So it's a nice series, but we know that by the graph. I would say it's a too nice series, but anyway. You have absolutely no difficulty to seasonally adjust this series, especially because you do not have the last, Here we are just in the first quarter of 2020. So it's likely that we will have a COVID impact just for the next quarter, if any, okay? And it should have an impact. So up to now, there's no difficulty to analyze this time series. Let me go a bit higher. I have two detected, you see, 41 observations. The series has been log transformed, so I will use a multiplicative model. No trading day effect, no Easter effect, because I ask for no trading day effect in my specification RSA1, and I have two detected outliers. So if I want to go and to check what are the outliers, let me go back to the real size. I have to go to pre-processing. So after main result, I go to pre-processing. And if I look to these strange results, we will detail them later. I see that I have two, in fact, two outliers at the very beginning of a series. So if I go back to the graph, it's there. It's in this part of the series. Look, okay, if I do, I can, you saw what I did? I can, because the interface is really interactive, I can focus on this part of a graph, just selecting the points, okay? If I do that, I have a selection. So here I have the outliers, which are not it's not very important in our seasonal adjustment because it's at the very beginning of a series. So we don't care what happens here. We are more concerned about what happens here. So it's very easy now to read. So let me show you the impact of that. So the impact is, I'm going to show you what here you see that you have a very small decrease, of a growth, okay? So if you do, for example, some growth chart, so tool container growth charts, I ask for that. Let me show you. I think I can do it. I can select the series, put it there, okay? So directly I have the quarter-to-quarter growth rate, so I cannot interpret it. If I want to interpret that, I will just comment the fact that for the first quarter is incredibly lower than the fourth quarter of the previous year. We know that because of the seasonal component. So we cannot comment the quarter-to-quarter growth rate on the raw data. But if I take the seasonally adjusted series, you see that I can compare it. I can do something. I can say that, for example, I'm still increasing. So I can remove it to see more things. You see, I can play. I'm playing with the data. I wanted to remove it, perhaps suppress. Yeah, I have just to suppress it. And here is the growth, quarter-to-quarter growth rate of a seasonally adjusted figure. So here I can say things. Okay, for example, I can say that the growth is slightly decreasing for a year now. Okay. So it was very high in the second quarter, around 3% of 19, okay, previous year. After it went to 2.3, and after 1.2, and now it's just 0.2. So it's decreasing, but the growth in Vietnam is decreasing for 1 year now. So you cannot see it on the raw data, but you can see it clearly on the seasonally adjusted data. So it shows you how important it is to seasonally adjust your data and to look at them. Okay. Do you have any question? Is there any question? Siska, do you see something? Do you hear me?
Yes, I'm here. There's no question in the chat box.
Okay. So what I would like people to do, because I did that for Vietnam, but you can do it for your own country. So I will give you some practical work just for a few minutes. Please take one GDP of your time, of your own country, and try to see if it is seasonal. So you go to the seasonality test, you check the seasonality, the presence of seasonality, and after you try to represent in the growth chart the quarter-to-quarter growth chart of your own time series. Okay, so it's really not difficult. You see, for example, you look at my table just before. You see that I'm just moving the first one. Okay, I will go to Indonesia, for example. GDP constant prices for Indonesia. If I click on it, everything is moving, you see? So I click on that, so I see that I have a clear seasonal component, and this is the growth rate, the quarter-to-quarter growth rate of my seasonally adjusted series, okay? So you see that GD Plus is completely interactive. If I change my series, I will get exactly the same results for the new time series. So for example, in current prices, I have this kind of results. It's still very clear, the seasonal component, I have no problem, and so on. So play with the software a bit. And if you have some difficulties, if you want me to do it again, I will do it with pleasure. Perhaps I leave you a few minutes to play with the software, and in 5-10 minutes, I will redo the complete exercise and answer to your questions, if any. Are we okay with that? Yeah?
Yes.
So try to do the job, and after I will close my GD Plus at the moment. I will save nothing. So I save nothing. And I will come back to you later. Okay, so now I have to. Okay, so I will stop to share my screen. I give you some time to make an exercise, and I will be more than happy to answer to any question you have. Okay, so this is the program for the last 20 minutes. You take 5 minutes to do the exercise again for your country. You ask questions, and in 10 minutes, I will redo the complete exercise with you, selecting one country randomly, okay? And after, I will answer again to question, if any. So be my guest, do the job now. Any questions, Siska? Everything is clear?
At the moment, there's no question. I'll ask also in the YouTube. The participant seems quiet. Hopefully they can follow.
You will be very, very soon completely used to move inside GD Plus. And during the week, we will see more and more output. And after we will try to synthesize everything to give you a global picture of a thing. Okay. So I let people work a bit, and after I explain. So if you have any question, general question, Siska, from you. No, is it okay? If this is,
At the moment, it's no question.
No, nothing, no remark, no suggestion, no?
Not yet. Not yet.
Yeah, I think everyone's play with the JDemetra now. Well,
No, it's not very difficult, but takes a bit of time to be used to this incredible graphical interface. Very, very nice and very easy to work with.
Just not a question, but if during the importing data in the spreadsheet, if we don't put the star, so if we reopen it again the next day or the next session, it will be gone, right? The data that we imported previously.
If we didn't put,
if we not put the star.
The star? What do you mean?
Yeah, in the spreadsheet.
The star?
Star. At the star in the spreadsheet.
Excuse me, I do not get
the spreadsheet. If we imported the data.
Yeah. If we forget the date, you mean?
No, the star. So we have to put star, so the data will be there.
I do not. Sorry, I do not understand.
Like here,
Siska, do you mean asterisk sign?
Why? Star in the spreadsheet. If we right click and the data, like add star or remove star. Star, yes.
You mean asterisk? I say
yeah.
I do not what I never saw any star in an Excel file. What do you mean by that? Show me, share your screen.
Okay.
What do you mean? I do not understand you. Sorry. Let me share my screen. I open the spreadsheet.
The JDemetra, yes.
In JDemetra, you mean?
Yeah, in the JDemetra.
You mean I have to, okay. Let me open GD Plus again. You see that, okay. So which star?
In the spreadsheet, the data that we already imported.
Let me, okay. For example, the GDP. Okay, where is the star?
Oh, still there. Because in the previous, when I work with JDemetra, if I don't put the star in the data, the spreadsheet, and then if I open the JDemetra again, they will gone the data.
You mean they are not in the recent file?
Yeah. I don't know why. That's why.
It's an option I do not know. Yes, it reminds me something. It rings a bell somewhere, but I do not. Yeah, you can put a star somewhere. I don't know. At star, yeah. But I don't remember what is the idea of this star. To be honest, I never use it. Okay, never. Okay. So I don't know what is the objective of this star. I do not know every feature in GD+.
Yeah, and I just try and error. So when I put star, the data still there. And then
Ah,
If I remove the
perhaps you
star,
mean, perhaps I put a star, okay? So the star is there. So let me close the, okay? And now I open it. And you mean I should have it there? Yeah, okay. No, I was not aware of this feature. Okay, so you put a star, you do not have to reload the data.
yeah.
So thank you, Niska. I was not aware of this facility. I can, okay, we can share it tomorrow morning when we will do another exercise. I can show people how to fix their, okay, that's a good idea. Thank you. Thank you,
There's a
Siska.
question in the chat room.
So what is the question now?
From Lao. They cannot open the JDemetra or the trade data set in the JDemetra. So maybe the way of importing the data. Mr. Yaifong, can you explain on the question? Mr. Yaifong?
So for the Lao, the data set we can import for the program as the open JDemetra can open for the example send the data ASEAN data for GDP and trade. So can open only show for the export information cannot show for the information for the quarterly program.
Can you share your screen maybe? You are using our data, right? The same data that we are using now?
I send you email my data set, so you can check for my data set.
It's not really clear, Mr. Yaifong.
Hello, Gary.
Yes, but to echoing is not really clear.
So you can help me here for the data set. So I'm not sure for the to the cooking for the data set or cannot import for the program this program. So I'm not sure how to do the cooking.
You want Dominique to show you again how to import the data, correct?
Yeah, I will show you again. But this is, to be sure, you are trying to read the same data set. The data set you received. Yeah, you didn't change anything in the data set. No?
The data set, the ASEAN data set plus import for the program, the numbers cannot work.
I cannot hear you.
I said my data set to Siska the email.
Stop. It's impossible. No, we do not hear you. There's too much echo.
Yaifong, you have to use the data set that already in the share folder, not your data set. The data that already prepared for this training, you have to use that one.
Could you send me your data? What you can do if you want to work on your own data, send the data to Siska or to me. I will prepare them. Okay?
Yeah.
Okay? That's so you can work after on your own data. Okay.
Yeah.
Because probably it's a question of date variable.
Yeah.
And the other question from Malaysia. Why my growth chart screen doesn't change accordingly when I'm choosing the different data or variable?
It's a curious question. Perhaps it's possible to share the screen to have a look
Yes.
to what's going on.
Miss Nurul Aini, can
Hey,
you
Mr.
share your
Dominique.
screen?
Hi, Mr. Dominique. Sorry, I cannot share my screen because I'm choosing another one screen.
Using the other
uh,
computer.
Yes. What I mean is based on show by Mr. Dominique last when I'm choosing the first I am choosing Malaysia GDP current price. Then I go to tool and choose for growth chart. The
Yeah.
first time I choose growth chart showing for GDP current price. Later when I choose the different variable, let's say I choose mining and quarrying, the first screen for seasonal adjustment processing change accordingly, but growth chart screen does not change.
Right, it's because, okay, it's because you, probably because you did the growth chart outside the seasonal adjustment. You see what I mean? So
Not really.
we will do the experience. Okay, I'm going to share my screen and to try to reproduce what you are saying. Okay, I will try. Okay, let me share my
Okay.
screen. Okay, so let me, okay, I will. So it's Malaysia, okay? So let me imagine first that I'm doing outside, I'm doing a growth chart. I didn't use, so growth chart. I have my growth chart here. Let us say that I put the current price, GDP current price in it. Okay, so I have it. Okay, so note that here, if I click on agriculture, it doesn't change anything. Okay, doesn't change anything. Okay, I click on mining, it doesn't change. But now I still keep it, but now I'm doing something different. I'm going to do a seasonal adjustment. Okay, so this is my data. I put just Malaysia for the sake of the exercise. I run it. Okay. Okay, so up to now, nothing special. So I go to this one, the same. So I'm still here, this growth chart, I will make it smaller for the sake of the example. Okay, this one a bit higher. Okay, so this is exactly the same thing. Okay, it's the same GDP current prices by industry. This is the same series. So now let me show you something. Let us imagine that I create a new growth chart. So it's another one. You see, I have a first one. I have a second one, which is empty. But now I'm going to use this series, okay? This one, which is inside the seasonal adjustment process. Or let us imagine that I take, for example, the seasonally adjusted figures and I put it in the growth chart. Okay, I do that. So now I go to agriculture. And you see that it changed because I am in the seasonal adjustment process. And the first growth chart, I'm outside. So it doesn't change. It's still GDP current prices by industry. But here, when I am in the interactive way, I am going to change things. Okay. So for mining and quarrying, this is the thing. Okay. Manufacturing, I have almost everything. Okay. So you see what probably happens in your situation. First, you do the growth chart, a static growth chart when you are outside the seasonal adjustment process, and that's okay. That's perfect. This is the growth chart you have here. You see, this is this growth chart, this one, for the current prices, GDP. And after, the second thing is that you do the same growth chart, but you are in the seasonal adjustment process. So now you are interactive. You can move from one to the other. Do you see what I mean?
Okay, Mr. Dominique, I got it.
Okay, so
Okay, thank you.
slightly different. Is there another question? No?
No more. At the moment.
Is it okay? So I will receive the data set from our friends, okay? And I will prepare it for them. I will check what's going on, come back to everyone to show them what was going on, and correct the mistake. Probably it's because it's not, it has to be prepared, and probably it's a question of date variable. So if there's no more question, perhaps we can stop right now. What do you think, Fatur, Siska? Is it okay?
I'm okay.
Yes.
Ailia, do you think we could stop now? Yeah?
Yes, Dominique. I
So
think
how
it's
do you
clear.
feel with GD Plus now? It's better, easier?
Yeah, it's better.
You will see, you will be completely fluent in 2 days. Completely. I'm sure. It's a very easy software. The difficulty is not in the manipulation of a software, which is very, very convenient. The difficulty is somewhere else. And you will see the difficulty when we are going to work with monthly time series.
Okay.
Is it okay for you? Okay.
Yes.
So we meet tomorrow morning. If you have a file from our friends, you send it to me. Yeah. Okay.
Yes.
Wonderful. So see you tomorrow morning.
Yeah.
Yeah. See you tomorrow.
See you
So
Oh
tomorrow.
yes, Siska. If you want to share the YouTube link, maybe to participant here, maybe they want to see again what we learned today. Do you have the link?
Maika will share because it's from the
No,
another
sponsor. This is from sponsor.
sponsor from Dominique.
I
The link
feel-
for the YouTube will be
I
sent
feel
later.
comfortable.
A bit
Me
stressed.
too. Yeah.
3 people answered a bit stressed.
You're still a bit stressed? Yeah. No, it's
4
normal.
people
You
a bit
should
stressed.
be. You should be still a bit stressed. But
Between
tomorrow,
comfortable and
it will be,
stress.
tomorrow it will be much better.
Okay.
1 person is
Okay.
lost.
I see you tomorrow. I'm going back to bed. You know?
Okay.
I think we can compare the answer today with and at the end of the course about this. How do you feel?
Okay. Yes, we could put it. Okay, bye-bye. See you tomorrow morning.
Bye. See you
Bye.
tomorrow.
Have a nice day. Bye-bye.
Have a nice day. Mr. Yaifong, if you can send your data set today, I can send it also to Dominique.
And maybe Mr. Yafong could test how he could share his screen. Maybe can you try? Can you try, Mr. Yafong? Just to learn this for the future, maybe good for you to learn to share your screen. Maybe could you share your screen?
Yeah, I think Mr. Yafong, you can share your screen and Fatur will help you. With your problem.
Yeah, at least you can learn to share your screen so the trainer could see what's the problem directly.
Yeah. For my data set, now I send to Siska email.
Have you clicked the share screen button? At the bottom, center bottom, there is a green bottom. At the bottom, green button.
I send Siska the email.
You mean that can you share your screen now so we can check whether you already able to use the JDemetra or not?
Okay. Okay, and now could you run your JDemetra? There is an icon there. I could see it. Mr. Yaifong?
So I use for the PC computer this yeah,
Mr. Yaifong, there is an JDemetra icon. Could you back to the main screen of your desktop? Minimize this. Minimize. Yeah, you see, yeah, that one. Double click. Okay.